I want to give you a quick little overview of naming polygons in general. The first day we talked about polygons, we talked about the common names up through 12, and I told you that there are names for every polygon beyond that, just not ones that you're necessarily expected to know and understand, but I do want you to see where they come from and why. And so this will go on page 102 in your ISN when we're done. Okay, so on the inside, okay, we got names of polygons, and it starts with number of sides over here, 1 through whatever. And we talked about the monogon and digon, or I didn't use those words with you that day, but 1 and 2 sided figures didn't really exist in Euclidean geometry. We'll talk about those in spherical geometry and some other stuff later on. But we really start with 3. Which is a triangle, and 4 for quadrilateral, but then on here it has trigon and tetragon. Over here to the right it says monogon and digon can only be used in rather special circumstances. Again, we'll talk about that. Trigon and tetragon are alternatives to triangle and quadrilateral. The adjective forms are more common. So if you would talk about something as being triangular, you could talk about it as being trigonal. It's still not that common. I mean, it's more common to use this form of it, but that's still not the most common word to use for it. However, once you get past the triangle and quadrilateral, you need those types of words to be able to build the other ones. And we'll look at that here in just a second. So we talked up through here. When we got to nonagon, an alternative word for that is enneagon. The nonagon is what we use. Then when we get to 12, okay, so we got decagon, and then there's undecagon. I said 12. When we get to 10, decagon. 11 is an undecagon, is what we use. But then you've got the hendecagon. That's just another option because you got different prefixes. 12 is dodecagon. Then 13 is a triskidecagon, and if you notice, like if you just kind of look down all these have this chi in there. It's kind of explained on the next page, but I'll just hit it right now. It means and, but it doesn't. It's not always used, because if you look at this, you got a pentadecagon. I'm sorry, a pentachidecagon and a pentadecagon. So this is 5 and 10, right? Which gives you your 15. Heptachidecagon. 7 and 10. That's where your 17 is. So it's in this form, not in this form. So it just kind of depends on where you see it from. So then you can see that what your different prefixes are. Icosa, that being 20, right? You got 21 or 20, 21, 22, 23. You can just kind of see how these are all built with the different prefixes. We'll actually build some here on the next page. All the way up. Keep going, keep going. And then you got 49 and then 50, and then the same pattern kind of repeats for that. So you've got a pentacontagon, and then go with the 51, 52, and so forth. 100, I want you to look at this prefix hecto, because we'll talk about that on the next page. 1,000 is chiliagon, and a 10,000-sided figure would be a myriagon. Okay, so the part gon, like for a polygon in general, has an interesting etymology. It's where words come from. Okay, it's ultimately derived from the Greek word gonu for knee, which they transferred to angle. The word goes straight back to Indo-European, is essentially the same in lots of languages. So gonu is Greek, ganu is Latin, knee is English, French is similar to Latin, German to English, except the K is still pronounced. Okay, so just a little FYI there, information stuff. I'm not going to ask you what a 53-sided figure is on the test. I just want you to be exposed to this. So over here, for polygons with 3 to 20 sides, you simply add gon to the prefixes. So here are your prefixes for 3 through 10. Then, of course, it says more commonly, we wouldn't really call this a trigon and a tetragon. We're more likely to call it a triangle and a quadrilateral, but we still need those prefixes for the others that we build. When you get up here, you've got the tens digit and the ones digit, because if you got more than 20 sides, you're going to construct the name, and that's what I wanted you to see, that all these are just these different prefixes all put together. So when we look at 3 through 99 sides, okay, we're going to construct a name. We start with the prefix and the tens digit, followed by chi, which is sometimes optional, which just means and follow with the prefix for the units digits. So a 35-sided polygon. When you look up here, 30 is triconta, that's where this comes from. Chi is the and, penta is 5. So a 35-sided polygon is a triconta chi pentagon. And if you just break it apart, that tells you exactly what it all means. The names are long and kind of crazy, but if you look at the pieces, it should make sense. Now, when you get over 100 sides, up to 1,000 sides, you have to have one more combining prefix. And so to construct the name, you have to start with the prefix for the hundreds digit and then the ones digit together. So that's why I told you, if you looked at 100 over to the left, 100-sided figure, it was hecto, it's right here, a hectagon, and then here it says hecta is 100, so hecta, hecto, depending on which version you're going to use, depending on how you put it together. But so a 672-sided polygon. Hexa means 6, hecta is 100, so that's where the 600 comes from. Heptaconta, that's your prefix for 70. Chi is and, 2 is die. So even though we don't have a digon, because we can have a 2-sided figure, you still have to have a 2 version for when you get up to the bigger numbers. So this is a hexahecta for 600, heptaconta for 70, 2 for die, so there's your 672. So that makes it a hexahecta heptaconta chi digon. Crazy name for a 672-sided figure. I am not going to ask you to construct these names. I'm not going to ask you what they are. I just want you to see why these prefixes are important to understand and what you can figure things out from them. And they have many purposes across lots of contents. So just in case you ever thought you couldn't actually name a figure that big, you actually can.